Hi, this is Siddharth Singh, and today we'll perform an experiment on OSPF, that is Open Shortest Path First Protocol. So, just like the RIP protocol, Routing Information Protocol was based on the distance vector algorithm. The OSPF, that's Open Shortest Path First, is based on the link state algorithm. The objective of or aim of the experiment is to configure and analyze the performance of the OSPF routing protocol. Now we know that the routers need to send the packets or data or forward it in the network. So they need to choose the most optimal path. So as the RIP was, it was based on the principle of it limited the hop count. It employed hop count as a routing metric and prevented loops by putting a limit on hop count. Similarly, OSPF works on the cost metrics. So it analyzes the cost and chooses the shortest path to make a decision. Now the total cost is basically the sum of individual costs on the path. So this is based on link state routing, where basic idea behind the link state protocol is quite simple, that every node knows how to reach its immediate neighbor, but it doesn't know or have information about the other nodes. So if this information is applicable to every node, then we can say that every node has complete information to create the whole map or topology of the network. So once a given node has a complete map, it's able to decide the best route possible. So this is calculating the routes is based on a well-known algorithm from the graph theory, the Dijkstra's shortest path algorithm. We'll start with the configuration. First, opening the object palette, we choose 8 of the routers. So we choose Ethernet 4 slip 8 gateway for this. We need 8 of them. Now, Ethernet 4 slip 8 gateway, it represents an IP-based gateway supporting 4 Ethernet hub interfaces and 8 serial line interface, and we connect them with the help of triple PDS3 link, which is a duplex link, and it connects two nodes running IP. It offers data rate of around 44.736 Mbps. After you connect them, this is the first scenario, no area scenario. After you connect them in this configuration, we need to assign costs for them. So we just go to protocols, OSPF, and so we'll select these three links first, and protocol OSPF configure the interface cost. We give the cost as 10 for these three links, for the selected links. Similarly, for these three links, the cost would be given as 20. And then we need to select the centermost links and assign them cost as 5. We go to the protocols OSPF, and the interface cost would be given as 5. So basically I've given the cost now. Now select routers A and C. Then we need to create traffic for that. So we go to the IP unicast, and from A, and you can set the bits per second as 1000. Create it. The one IP unicast is created. Similarly for the nodes B and H, we create traffic. So create traffic IP unicast. So from node B, we are creating traffic to all the other selected nodes, that is from B to H. With again the bits per second as 1000. Once you do this, you can just go into the view and demands show all, which will help you show the traffic here. So right now we do not need it. Close it. So that's how your cost links have the cost. Next, you go to the now we select all the links with the configure with cost 5, and we go to the protocols IP routing, configure the routing protocol. and we make sure it's selected to OSPF. So we do not visualize it, we just click on the OSPF. Now we select routers A and C, and BNH we have created the traffic already. So make sure it's protocols IP, go to the port routing table, for these two we go to the IP routing export routing table for the selected nodes. So what we're doing is we need to auto assign IP address as well. Just go to A and B. You go to the protocol IP routing, protocol IP addressing, and just you do auto assign IP and click OK. So basically auto assign IP, basically it assigns a unique IP address to connected IP interface whose IP address is currently set to the auto assign. It doesn't change the value of manually set IP addresses here. After we do this, we create a new scenario. So we duplicate the scenario basically. Before that, we just click on this icon. For 10 minutes, we'll just apply and run the configuration. Once it's run, you can just close it, and then we click on the scenario and duplicate scenario. You can just make a new scenario, which is area 1. So we just switch it to area 1 scenario. Here we'll assign areas. So you select the first 3. And we go to the protocols OSPF and configure the areas. We'll set it as 0.0.0.1. Similarly, we'll set these 3 links for which the cost is 5. These 3, we go to protocols OSPF, we configure the areas and make it 0.0.0.2. So we have configured areas. Next, we click on router C and just go on the edit attributes. So we go to the IP routing protocols in that OSPF parameters and loopback interfaces, and make the area ID as 0.0.0.1 if it's not there. That is selected nodes obviously, and just do it. So loopback interface, basically it allows a client and a server on the same host to communicate with each other using TCP/IP. After that, so the area you did not configure, the middle center one, is the area identifier, that's 0.0.0.0, and the other two we have named as 0.1 and 0.2. Next we go to the no area scenario and then again duplicate it to create a new scenario which is the balanced one. Now we select router BNH in this case, and in the protocol's IP routing we configure the load balancing options, which should be packet based. So we need to choose it packet based for the selected routers. Now with packet based, we see load balancing is done on a per packet basis and not on the destination basis. That is, each packet may take a different route. Okay, so from the source router to the destination network, so the route chosen for each packet is redetermined for the individual packets. While with the destination based, you can say the load balancing is done on a destination per basis, not on an individual packet basis. And here you can say the route would be same for all the packets. So you choose packet paste, and okay, for that click OK. We run the simulation for 10 minutes as well. So you need to run the simulation for each of the scenarios. Just run it for area 1 as well. Once you do that, just go into the now we can just go into the protocols IP demands and display the routes for the configure. So this is for the area network area scenario. We can see the area. We can just zoom in for clarity. Just click on yes, and we can see this is the path. So we see this is the OSPF protocol has chosen this path. So here the metrics is basically the cost on which we are seeing it. And for the B2H, that is the two routers which completed, this is the path taken. Switch off this. And yeah, for the B2H, this is the optimal path, adaptive path which is being taken. This is for the area scenario. You'll see the first with the no area, and yeah, we go to the protocols IP and then demands, and then click on display routes for the configure traffic. Again, that's the source node A and C. Just click on yes. So this is the path taken to reach from A to C. And for the other two routers B and H, this is the path taken. So, and lastly for the balance scenario, we go to the balance scenario and IP demands display route. Again for the source A, we can see this is the optimal path taken. And for the B2H, this is the path taken. So OSPF basically it's a supports hierarchical routing by allowing the domain to be divided into multiple areas, as you saw in the area scenario, and for better manageability and scalability. So in OSPF, the routes that are learned by a router from OSPF sources within the same area known as inter-area routes. Routes that originate from an OSPF router in different areas are considered as inter-area routes, and certain networks could belong outside the area. So those are known as external routes. So we see that a router within the domain doesn't necessarily need to know the entire network. It should know the information about neighboring nodes, and so it will be sufficient for it to know how to get the right area. It may just know the area and not the entire domain. So here we saw the OSPF as a routing protocol for the three scenarios: area, no area, and a balanced scenario, where there was load balancing, where it is a per packet based on per packet basis, the load balancing. So each packet can take different routes. Thank you.